Hey class, today we're going to talk about heat transfer, which is appropriate. It's pretty cold outside today, and there's probably a lot of heat being transferred from this conditioned space that I'm in, and probably you're in too, through the building materials, through the exterior. The equation that we're going to talk about today is related to heat transfer through conduction. Okay, so we're not going to talk about heat that's transferred through other means like radiation or convection. Okay, so just conduction. And the equation that you can use to calculate heat transfer through conduction is calculated by finding Q. Q is what we're searching for, and that's heat transfer, and it ends up being in units of BTU per hour that's transferred through a material. And Q equals a variable which I'll talk about in a second, times area in square feet, multiplied times a change in temperature, which will calculate using degrees Fahrenheit, so English units here. So we can find heat loss in BTUs per hour by using a variable called C, or conductance. Now, as we know, different materials conduct heat differently. A metal is going to conduct heat faster, or in more BTUs per hour than, let's say, a piece of gypsum board or a piece of insulation. So you can calculate conductance by understanding or knowing what's called conductivity, and we label conductivity as K, over thickness. And the industry notes thickness in this case as D. So the variable that we need to plug in order to find the heat loss in BTUs per hour through a material is the conductance. And again, conductance is conductivity over thickness. So let's consider a piece of gypsum board. And this gypsum board, we'll try to find its conductance first. The gypsum board has a conductivity of 2.25, and the units for this conductivity are inch BTUs, okay, over hours per square foot per degree Fahrenheit. So this is C of gypsum board. All right. Now, if we know that the gypsum board we're working with is a 1/2 inch thick, we can essentially divide by or multiply by 1 over the thickness of it. If it's a 1/2 inch thick, the inches in this case would cancel, and we would end up with a conductivity of dividing by 0.5 is the same thing as multiplying by 2, right? So the conductivity of gypsum ends up being 4.5, and our balance of units here, which would be BTU over hours per square foot times degree Fahrenheit. Well, let's go ahead and plug that into an equation to calculate the overall heat loss through one piece of gypsum board. And let's say it's a day like today where it's pretty cold outside. Let's say it's 30 degrees outside, 65 degrees inside, okay? So we just calculated that the conductivity, I'll get rid of the units here so we have a little more space. So in this case, the heat transfer through the gypsum board is going to be our 4.5, and the units end up being, for conductivity, or C, BTU per hour per square foot and degree Fahrenheit. One piece of gypsum board is probably 4 by 8 as a standard size. So 4 by 8 would be 32 square feet. And that change in temperature I just mentioned, if we consider it to be 65 degrees indoor and 30 degrees outdoors, that would be a 35-degree temperature difference. So if we just look at the units first, we see degrees Fahrenheit cancel, square feet cancel, and lo and behold, we're left with BTUs per hour, which is what we're trying to find in terms of heat transfer via conductance. So now we just need to do the math. And I end up with a heat transfer of gypsum board, and this is just through one piece, of 5,040 BTU per hour. Now if you're thinking, wow, it would take a long time to consider a full building and all of its materials, and also consider the temperature change that would be happening sometimes on an hourly basis in our state. So I just want to sort of ease your thoughts by saying that most of the time when you're doing building modeling, the heat loss through conduction is calculated using software, and it can run, you know, hundreds of thousands or millions of calculations for each hour of the day, considering the temperature changes and also the difference in building materials, because of course a building won't be just one piece of gypsum board. It will have windows and various pieces of insulation. So this is just one snapshot at a look at heat transfer. I think that you should also realize that you are already likely familiar with a couple of other heat transfer factors. For example, R value, does that sound familiar? Or U value? Well, if you know R value or U value, you can relate them to conductance, what we just talked about. The U value is the same thing as the C value, which means if you happen to know the conductivity and the thickness, you can calculate the U value. The U value is just considered a transmittance value or thermal transmittance value. And perhaps you're also familiar with an R value. An R value is a thermal resistance value, and it can be calculated by taking 1 over U, 1 over C, or the reciprocal of transmittance or conductance, which is D over K. So you will need to manipulate and utilize these equations for calculating heat transfer. And I've had to use these equations in real life, not so much for building modeling, but for calculating the insulation requirements for piping and what the heat loss would change would be if you insulated some piping. So I hope these equations are helpful in determining heat loss via heat transfer. Thank you.